Two borrowers obtain loans at the same time. Each loan is for the same amount and is repaid with level end of month payments. First borrower is charged monthly effective interest rate of I and makes payments of P for K months to pay off the loan, where K is a positive integer. Second borrower is charged with monthly effective interest rate of J and makes payments of 120 for 5K months. You are given that J is between 0 and 0.04 and I is equal to 1 plus J to the 5 minus 1. Determine which of the following statements about P is true. So the loan of each of the borrower is being paid off as an annuity immediate because it's end of month payments, and it's the same for both. So let L be the common value of the loan, and the equation will be loan, the first borrower, it will be L is equal to P 1 minus 1 plus I to the negative K over I, where P is the payment, the monthly payment for the first borrower side. First borrower makes payments of P, and these are both of them are making monthly payments, and the monthly interest rate for the first borrower is I. So therefore, our basic annuity immediate equation gives L is equal to P. So L is the present value. P in this case is the payment. Usually we use X, but here we are using P. 1 minus 1 plus the interest rate power negative. Usually we have negative N here, where N is the number of payments. Here we are told that it's K payments. So 1 plus I to the negative K over I. And now for the second borrower, we are told that the monthly payment is 120. And so we'll have 120 here for the second borrower instead of P. And then the interest rate for the second borrower is J. And the number of payments is 5K because the second borrower pays payments of 120 for 5K months. So the time for the second borrower is 5K months, and each payment is 120, and the interest rate is J. So that's why we have 120 here, we have J here and here, and we have 5K over here in the basic annuity immediate equation. And now from 1 and 2, we can equate them, but first we also have to make sure that we don't have both I's and J's running in the same problem. So for that, we are given that last condition that I is equal to 1 plus J to the 5 minus 1. So this one, when we add 1 to both sides, gives us 1 plus I is equal to 1 plus J to the 5. And now we can substitute the value of 1 plus I from 3 in 1. So 1 then becomes L is equal to P 1 minus, so 1 plus I will be replaced by 1 plus J to the negative 5. So when this becomes 1 plus J to the negative 5, it becomes 1 plus J. The negative 5, the 5 gets multiplied with the K, and you end up with so not negative 5, but 1 plus I gets replaced with 1 plus J to the positive 5. And so the positive 5 multiplies with this negative K to give us a negative 5K. And we have L is equal to P 1 minus 1 plus J to the negative 5K over I. And from 2 and 4, so we not have gotten it in just terms of one interest rate. We still have I's and J's running around, but we are taking steps towards that. And so from 2 and 4, we see that 120, 2 says 120 times all this quantity equals L, and 4 says this whole quantity equals L. So that means 120 times this whole quantity equals this whole quantity. And now the 1 minus 1 plus I, 1 plus J to the negative 5K cancels out from both sides. And so and this I moves on into the numerator. So if we solve this equation for P, we get P is equal to 120 I over J. And now we replace the I back with what was given. I was 1 plus j to the 5 minus 1. And so this equation becomes p is equal to 120, 1 plus j to the 5 minus 1 over j. And the reason we did that is that we are now going to use the condition that's given on j. We are told that j is between 0 and 0.04. That's what we were told here. And so we have to find the bounds of p. So we are given the bounds of j, and we have to use those to find the bounds of p. So j is strictly bigger than 0 and strictly less than 0.04. And therefore, to find the corresponding bounds for p, we'll have to take the limits at these two numbers, because we're not equaling 0.04 and we're not equaling 0, but we are being as close to these as possible. And therefore, when you take the limit as j approaches 0.04 in this equation for p, we can here directly plug in 0.04, because here we are not having any issue. Remember that in a polynomial, if you can directly plug in the number and you're not getting a 0 in the denominator, then that direct plugging is going to give you the value of the limit. And so this gives you 120, 1 plus 0.04. We're plugging in the j value as 0.04 minus 1 over 0.04. And this gives us 650. And now for the lower one, its limit j approaches 0 of all this quantity. Now here, if you try to plug in j is equal to 0, you're getting a 0 in the denominator. And in situations like this, and also if you see, we will get a 0 in the numerator here, because it's 1 plus 0 to the 5, which is 1, and 1 minus 1 is 0. So anytime you get 0 divided by 0, you know that you have to use L'Hopital's rule, which says that you take the derivative of the numerator, so that we can pull the 120 out of the limit. And the derivative of 1 plus j to the 5 by power rule would be 5 times 1 plus j to the 4. Derivative of 1 is 0. And divided by the derivative of the denominator, and the derivative of j is just 1, because we can think of j like the x. So the derivative of x is 1, and the derivative of 1 plus x to the 5 is 5 times 1 plus x to the 4. And now we can substitute j is equal to 0. Now we don't have the issue of the 0 denominator. Denominator has become 1 after taking the derivative. And remember that L'Hopital's rule is not quotient rule. We're not taking the derivative of this whole thing. We are taking the derivative of just the numerator on the top and dividing it by the derivative of just the denominator in the bottom. So now when you plug in j is equal to 0, this 5 gets multiplied with this 120, 1 plus 0 to the 5, that's 600. So with 0, we're getting 600, and with 4.04, we're getting 650. And we were plugging both of these values of j in this p equation. So that means p is between the 600 and the 650, and that is choice E.